In Lesson 3.2, we will discuss logarithmic functions. In Video 3.2.1, our learning target will be for students to evaluate expressions involving logarithms. In Lesson 3.2, we will be discussing logarithmic functions and expressions. Before we do this, we need to review some information we learned in Lesson 1-7. In that lesson, we discussed that graphs of functions passed the horizontal line test and are said to be one-to-one and have inverses. Now, looking back at Lesson 3-1, where we have discussed the graphs of exponential functions, you can see that the graph of an exponential function passes the horizontal line test and has an inverse. This should be thus, has an inverse. So if we look at this black function here, this black line or curve, I should say, f of x, it passes the horizontal line test, right? If I draw a horizontal line through it, no matter where I draw that horizontal line only intersects our function at one point. That tells us that the exponential function has an inverse and it is one-to-one. Now, what does that inverse look like? That is what's graphed here, f inverse of x. That inverse is going to be a logarithmic function, and we know that graphically inverse functions are reflections of one another over the line y equals x. Thus, why they have that dotted y equals x line there. If I folded our piece of paper on that dotted line, the two graphs would match up perfectly. In this slide, we are going to discuss relating logarithmic and exponential forms. If b is greater than 0 and b is not equal to 1 and x is greater than 0, the logarithmic form of a function is log base b of x equals y. That is how I say that expression there, or that equation. Log base b of x equals y. Now, that's only true if and only if b to the y is equal to x. b raised to the power of y is equal to x. Now, the reason why this all happens is we just discussed on the last slide that an exponential function excuse me, and a logarithmic function are inverses of each other. Now, if you remember, the general equation for an exponential function is y equals b raised to the x. A logarithmic function, then exponentially, written as an exponential function, is going to look like x equals b to the y. Hence why they have this exponential form written here. Now, x equals b to the y is an exponential form of, or another way to write, log base b of x equals y. Now, most functions need to be written in explicit form where y is by itself. Therefore, we need to be able to write our equations in both forms, in both exponential and in logarithmic form. But one thing that is important to remember is all inverse functions can be found if you're given the equation of one function. The next function can be written by switching x and y and then solving that equation for y. And that's what's done here, is how they got this logarithmic form is by solving this exponential form for y. In example 1, we will be asked to evaluate logarithms. It says to evaluate log base 2 of 16. Now, what you need to know is that a logarithm, the word logarithm means exponent. Okay, the word logarithm means exponent. Now, what I want to know here is if I have log base 2 of 16, what I'm really looking for is 2 to what power is equal to 16. What we're trying to solve for in this problem is x, an unknown exponent of this function. Now, Now, if you think to yourself, okay, 2 raised to what power is 16? Well, we can do a little work on the side here. 2 to the first is 2. 2 squared is equal to 4. 2 cubed is equal to 8. And 2 to the fourth would be 16. So my value of x in this logarithmic expression is x equals 4. In example 1, part B, we're evaluating logarithms again. In this example, we're asked to evaluate log base 5 of 1 over 125. Now, what we are looking at here is we have 5 to the x power equals 1 over 125. Remember that a logarithm is just an exponent, so when we're asked to evaluate log base 5 of 1 over 125, we're essentially asking what is the exponent on a base of 5 that gives us 1 over 125. Now, if we think about some values here, 5 to the first is 5. 5 squared equals 25. 5 cubed equals 125. Now you can see that as x increases, so does our output. And we want our output, or our x value, to give us an output of 1 over 125. So that means that I need to decrease my exponent. So 5 to the 0 power is going to give us 1, because anything raised to the 0 power is 1. 5 to the negative 1 is 1/5. 5 to the negative 2 would be 1 over 25. And 5 to the negative 3 is going to be 1 over 5 cubed, or 1 over 125. Anytime you have a fraction as your output here, that means your exponent is going to be negative. So we will say that the value of x is negative 3 here. 5 to the negative 3 power was the equivalent of 125. So log base 5 of 1 over 125 is negative 3. In lesson 3-2, example 1, part C, we are evaluating logarithms still. Here we have log base 3 of 1/27th, and I want to know what the value of that logarithm is. Now, since the word logarithm means exponent, we're saying base 3 to what exponent is equal to 1 over 27. We just learned on the last slide that if our output, or we're evaluating a logarithm of a fraction, then our exponent has to be negative. Here, 3 to the 0 is equal to 1. 3 to the negative 1 is 1/3. 3 to the negative 2 would be 1/9, or 1 over 3 squared. And 3 to the negative 3, I should just skip down here. 3 to the negative 3 would be 1 over 3 cubed, or 1 over 27. So x here is also negative 3. Now, in example 1, part D, we're going to evaluate log base 17 of 17. So essentially what we're saying here exponentially, if I set this equal to x, which is unknown, we're trying to solve for x or find x, I'm asked exponentially, if I rewrite this logarithm exponentially, it's 17 to what power gives me 17? Okay? Now, anytime you have some base raised to a power and your outcome or your output is the same number as your base, then x is just going to be equal to 1, because anything raised to the first power gives you that same number back. So that kind of brings about a property of logarithms, in that if you have any logarithm base b of b, right? If this base and this number you're taking the logarithm of are the same, then your output is just equal to 1. In example 1 guided practice, you will be evaluating logarithm base 4 of 1/16 is equal to y. Okay, in this example, they're using y as their unknown variable instead of x, like I did. Now, what I want you to figure out is the value of y. You have 4 choices, A, B, C, and D. I would like you to work out this logarithm and then submit your answer.